Let's continue our discussion from last week about Boolean expressions, and we're going to learn a few things that are more in depth. So first, remember that Python will let you evaluate any built-in data type as Boolean. For numbers, that includes integer, float, and long ints. 0 is considered false, and any other value is considered true, and that includes negative values as well. For a sequence, any kind of sequence really, an empty sequence is considered as false, while any non-empty sequence is taken to mean true. So remember, a sequence can be a string, a list, or a tuple, or a dictionary that we have not actually learned. But take a sequence as a list or a string for now. The Boolean operators have operational definitions that make them useful for other purposes as well. So let's see them. So for the way Python might evaluate AND, so far the both side of AND that we learned were Boolean expressions themselves, but X and Y can also be regular values. So in that case, Python will interpret X and Y as if X is false, return X, otherwise return Y. It also means that return in the end case, return the first false or the last. In the OR case, X or Y, if X is true, return X, otherwise return Y. In other words, return the first true or the last expression. So in the NOT case, if X is false, return true, otherwise return false. So let's see some examples. Here, X is 1 and Y is 2. 1 and 2 will return either the first false or the last true. So in this case, it will return 2. In the next example, 0 and 2. So read 0 is false, so we'll return 0. 1 or 2. 1 is true, so the first one is true. We'll return 1. 0 or 2. The first true is 2, so we're going to return that. And here's another example, and this time we have 0 or and Boolean expression, which is 1 less than 0. 1 less than 0 is false, so 0 or false will return the last, which is false. Here's another example regarding not. Remember, 1 is true, not 1 is false, and 0 is false, not 0 is true. Okay, so let's move on. So we can use Boolean expressions as decisions as well. Let's look at this example. Answer is an input and the prompt is what flavor do you want? It also means that if you don't hit type anything, it indicates that vanilla will be the one. Okay, so we can say if answer and flavor is answer, else flavor is vanilla. Okay, so if the user just hits enter, the answer will be an empty string, which is false. And in that case, vanilla will be the flavor. Otherwise, whatever user type, it doesn't even have to be a valid flavor. But as long as, in this case, of course, as long as it is not an empty string. Okay. So we can code this even more succinctly, shortly basically. We can say answer is input, what flavor do you want? And the flavor can be answer, ans for short, or vanilla. Remember, in the OR case, we return the first true or the last one. So if answer is true, we'll return whatever the answer value is. Otherwise, we'll return vanilla. So vanilla will be assigned to flavor. This exercise could also be boiled down to a single line of code. Of course, it's going to be long, but flavor is input, what flavor do you want, or vanilla. So it's basically taking these two lines of code, condensing into one line. I do, however, suggest this way is more descriptive. It's more explicit. Okay, so let's see some more examples. We can put these operators together to make arbitrarily complex Boolean expressions. The interpretation of the expression relies on the precedence rules of the operators. So consider A or not B and C. It's because it's a pretty complex Boolean expression. So how do we evaluate this? The order of precedence is from high to low is not and or. Of course, the parentheses always have the highest precedence. So this statement is equivalent to A or not B and C. So first we're going to evaluate not B, then not B and C, then A or the result of this sub-expression. Since most people don't memorize the Boolean precedence rules, suggestion is that we use parentheses to prevent confusion. So let's move on. Let's look at a volleyball scoring example. To win, a volleyball team needs to win by at least 2 points. And a team wins at minimum 15 points. So if the score is 15 to 14, play continues just as it does for 21 and 20. So there has to be, one team has to be at least 20, to have at least 15 or above, or and at least 2 points difference. So we can write a Boolean expression. So A is team A, and then B is team B. We can say if A is greater than 15 and equal to 15, and A minus B is greater than 2, this is one win case for A, or B is greater than 15 and B minus A is greater than 2. So in this case, we have a winner. Okay, so we can also rewrite the same thing as A must be greater than or equal to 15, or B must be greater than or equal to 15, and the absolute value of A and B must be greater than or equal to 2. So, and to write a program that will continue playing the game until one of the team wins, we can say continue playing. So while not, the parenthesis is a win case, while not win, right? And a win case is just the one that we described here. Okay, so while no one is the winner, basically, continue playing. Okay, so finally, let's talk about Boolean algebra. The ability to formulate, manipulate, and reason with Boolean expressions is an important programming skill. Boolean expressions obey certain algebraic laws called Boolean logic or Boolean algebra. So AND has the properties similar to multiplication, or has properties similar to addition, and remember 0 and 1 correspond to false and true respectively. So here's an example of Boolean algebra. So A times 0 is 0, A times 1 is 1, A times 1 is A, and let's get rid of this. And then A plus 0 is also A. So in Boolean algebra, A and false, remember 0 correspond to false, and A and false is false. Okay, and A and true is A or false is A. Okay, so anything or and with true is true. Anything or and with true is true. So A or true is true. Both and or distribute. So A or B and C is equal to A or B, and A or C. A and B or C is A and B or A and C. So double negatives cancel out. So not A is A. And the Morgan law says that not A or B is equal to not A and not B, and not A and B is equal to not A or not B. Okay, so with this, let's see some examples in the editor. Boolean examples again. So the first thing we learned that we can say 1 and 2 will return the first false or the last. So there's no false here, so it's going to return the 2. So 1 and 0 will return the first false, which is 0. Okay, so 1 and let's say -1. Remember, -1 is also true. It will return the last true. Okay, some of the again, if the first one is 0 and 5, it will always return the first false, which is 0. And let's see some OR examples. So OR example is the first true or the last one. So 1 or 4. Remember, in the AND case, if both true, it will return the last one. In the OR case, it will return the first true, so it will return 1. So again, if the first one is false, it will return the second one. So 0 or 3 will return 3. So if the first one is false, we can say OR, and I can put true here. It will return the last one, which is true. Okay, so not will negate, so not 1 is false, not 0 is true. So again, remember, as far as the numerical values go, 0 is the only false. Anything else is basically true. Okay, so we can also have we can say remember our vanilla example. So we can say vanilla or okay, what favorite? Let's say lemon. Okay, vanilla or lemon. Remember, we'll always return the first true. Okay, so and we can also say this or vanilla. So this is false, so we'll return this vanilla. Okay, and what else we can do with this? We can say let's do AND vanilla and lemon. It will return lemon because if both are true, it will return the last one. Okay, so that's how we could do use Boolean expressions as decisions. So in our next example, we look at the some compound Boolean expressions. Let's say volleyball A score is 14 and then score B is 13. So do we have a winner or not? We can say, so A must be greater than or equal to 15, or B must be greater than or equal to 15, and the absolute value of A minus B must be greater than or equal to 2, or greater than 1. If you want to say greater than 1, that should also work. So the false means that we don't have a winner. So if let's change the values. If A is 15 and B is 14, do we have a winner now? Let's rerun this. And it's still false. We don't have a winner. However, if we say A is 16 and then B is 14, and we should have a winner now. Yeah, there is a winner. All right, so let's move on to loops again.